So please tune in on Wednesday for the next session, which will be showing the integration of BI tools and the ModelOp Center and how we use that to actually determine both the statistics and performance and the KPIs and et cetera, and measure the business value behind what your models are doing within your company. But today's focus is on designing a model lifecycle. We've talked about the model lifecycle before as a process, and basically as a reminder of the architecture of what we're demoing today, we will be running live on Kubernetes, and we will have our model lifecycle server will be the focus of today. Of course, the whole value in the Model Lifecycle Center is its orchestration of all of our other microservices and components, which is what we'll be doing today, interacting with both runtimes, where we'll be executing models and test jobs, also with Model Manage, where we store the metadata, et cetera, that we have out there. So we'll be showing how to build those up. And like all of the sessions, we will have a large portion of this is hands-on. We're going to design kind of a hello world model lifecycle, and then we're going to design a more real one where we do something with the models on that. But today we do have a few more slides as background so you can better understand what we're actually doing about the different components, because it's a very complex process on how to do these model life cycles. We're using that BPM engine underneath to actually drive all these processes with our additional delegates and signals and service tasks. I want to explain what those are up front, and then a little bit briefly about some of the ones that we actually are going to be using today, and then we'll jump in hands-on and actually build something. So we're going to lay a little more groundwork than the previous sessions up front today. So BPMN, that's basically, we're using a BPM engine, but BPMN is basically business process model and notation. It's actually the way we basically can lay out that business process and that flow that we're going to be doing today. So unlike some of the other kinds of technologies you may have seen, where things such as Airflow and others that are meant to basically lay out a simple process, more of a batch-oriented process that probably occurs over a fairly small amount of time and may make some minimal decisioning. BPM is really designed for these long-running business processes, including processes that may span months and make many decisions and flows and involve external things that have to happen outside of the control of the BPM engine and things like that. So it's really designed to model these kinds of things and fits very well with describing a model life cycle. Cycle will involve human reviews, will involve maybe report generation and confirming things. It may involve 30 days of testing out in an environment before it's allowed to proceed onto an actual deployment. So there's all kinds of things. So there don't tend to be these simple batch job type constructs. They tend to be that much longer flowing and taking many different forks depending on outcomes of all those situations. So that's where BPMN does a very good job at letting us build up those kinds of descriptions and things like that. It was originally the 1.0 version goes way back to 2004, so this isn't brand new technology. It's been around a while, but we'll be using the version 2X of it today, which was actually formally released in 2011. We will be using modeling tool for today's demo to actually build these things out in the drag and drop style and edit them on that kind of things. But to be very clear, there's lots of different tools out there. You may already have this existing within your company. We are not tied to any specific tool. As long as it's a BPM version 2, we're good to go with uploading that into our server today. Underneath, it's XML, and we'll look at that briefly, but there's absolutely no way most people want to design a process using the XML version. It's very unreadable, to put it bluntly, and so that's why all these graphical tools exist to actually do that. And also, there's almost no way you can visualize the XML into understanding what it's describing, but the graphical representation is very clear once you know the notation to be able to follow it through, much like a flow chart or that kind of thing. So it provides us that kind of a capability. So there's several constructs. As I said, I'm going to go through a few slides describing the overall higher level constructs of what goes into a BPMN document. So that way you can better follow along when we get hands-on with it and understand what we're doing. It's all about the process. basically like that. So, a single diagram will describe a single process that pulls together, as we see here on the right-hand side. It uses a different collection of BPM elements and connects them with flows, and then we'll look at some of the gates and other items out there that allow it to actually make decisions. So there's a process definition at the highest level, and that's what we'll be doing up front, is actually building process definitions. We'll build a couple of those today. Now, once you have deployed a process definition, then you get process instances. And that's what the idea is. Once a process starts, you get a process instance that actually contains kind of the state of where it's at. You can have many of these that start and run in parallel, and you can track those individually. So this one on the right, and don't worry, I don't expect you to actually read it, but it's when a new version of a model happens, one we've used in the demonstration here, how we actually flow through it. Obviously, there can be many of these running, many in parallel, and they could run over months. I mean, it could take 2 weeks, 3 weeks to get a review out of somebody on that kind of things. And so we'll have those all individually tracked as those instances. And then within the process instance, we're going to be using process variables today quite a bit. Process variables are just like any other variables. They actually store specific values, and those variables are specific to the instance. So that's how we can store, for instance, like a good example is what model was actually changed. That starts out this process. We need to have that in the variable so we can access it. It can be a simple like numerical or textual value in its simplest form, but it's actually kind of an object. Underneath it's a Java object, but you can interact with it with things like Ruby and other things as well, which we'll be doing some of today. So that actually carries the state that is going on in the process. So you can know about things like which model was changed, what job am I running, and feed it between these different elements within the flow. So they become the communication of running the basically between each of these individual activities, which we'll talk about in a minute. So there's a few different major classes of elements within the BPMN diagram, and we'll be using all of these today. So I want to start out with an introduction to the events. Every process has to start for some reason. They're not just generically run. So we have start events that can basically begin the process on a variety of different conditions that can occur. So there's this concept of signals. We use those quite a bit in ModelOp Center, because what they do is basically say, hey, when this occurs outside of my system, please let me know and start the process. So we'll be doing that today with things. A good example is like what we just showed a minute ago is when a deployed model is changed, et cetera, and things like that, or when something, an execution starts, or those kinds of things. Those are signals that occur and allow us to start the process and also capture some information into the variable about exactly what happened. So for instance, we can capture the specific model that was changed or the job that started. We'll have access to that to know what's there. Another common start event type you'll see out there is the timer event. Now, these timers can occur in a variety of different things. They basically can take a full cron expression, so you can do anything that cron can do. They also take some simpler notation, like if I wanted a reoccurring event that runs every 30 seconds or every minute or that kind of thing, we can specify that within there as well. And then they will start a new process at that interval. But you can also use it for like the last day of the month or the first of things. We've got to run our, we want to rerun our tests every 30 days. But we can do those kinds of things as well and start out these processes. And then just like there's a start, there has to be a finish to the process. We don't want processes just hanging out there indefinitely with no resolution. So we have the idea basically of the end events you see over here. So for instance, we have things like terminate. That just basically means end the process normally. So, it's considered complete and it is done. Likewise, like you have start signals, you can also have end signals. So we could send out a signal saying this process is completed. Now, other processes could then be listening for that signal and then actually be initiated by another process being completed. So you can actually chain processes and have one process complete and end up firing off another 5 processes for all you know. You want to be careful doing that because it gets really tricky to debug them all and link them together if you do that. But in some cases, it very well may make sense that some things need to be done once that process is complete and be done in a consistent manner across all processes. And that's a great way to link those out. And it's finally, there's the concept of an error end event too. Like if things have gone wrong, the process should be considered in error and needs to be reviewed. We can basically say that this process ended in an error, and we can detect those and deal with it as well on that kind of things as well. There's other kinds of end events as well, but these are the most common, and we'll do that. And then kind of the final kind of event you'll see, and we'll actually use today as well, is the idea of an intermediate event. It's meant to basically interrupt an activity, and we'll talk about activities here in the next screen. But the idea is, let's say, for instance, there's this activity going on, and an error occurs while that activity is going on, we can actually capture that and specifically take a path based on that boundary event. Another example could be like a timeout. We could put one of these timer events on an activity as well and say, hey, if it doesn't complete in a day or an hour, go ahead and we're going to kill that job, or that kind of thing. So we can implement timeouts and things like that as well, where we can do that as well. So we have all different kinds of things. We can take any of those events and actually make them boundary events, which means they basically can potentially interrupt an activity. And with activities, the idea is that's where we get our work done. That's where we do stuff. And we're going to be using a lot of those today. The whole series of different ones, there's user activities. I mean, literally a human is doing something and has to manually say that is done. There's also business rule activities where we can actually execute decision tables or CMMN or a variety of other different things to basically go through and automate and compare data to go out and do things. We have script activities, which we'll be using as well, that can execute any arbitrary script. We'll be using Groovy today is our scripting language, but there's a wide support for a variety of different scripting languages for kind of small amounts of work you may need to do to change some data or massage one of those process variables or look at the data in the process variable in order to make a decision on that kind of thing. There's also the idea of sending out messages to things such as emails or manual activities that literally somebody would have to physically pick up and move something. We're not going to be doing either of those today, and the manuals usually don't apply to a model lifecycle, but I did want to bring those up as items out there. The main ones we're really going to be using at, and what's important to ModelOp Center, is the idea of service activities, because they basically, one example of a service activity is a Java delegate. We've implemented a bunch of different delegates, and we'll give some examples, and we'll use some today, where we can actually go out and do things and interact with the system on that kind of thing. So we'll be using those heavily, and that's what we've provided, a big collection of things to actually interact with the ModelOp Center. And there's also another one we'll be using heavily, because this is the reality in enterprise solutions, is that basically we have the concept of external activities. External activities are things that aren't under direct control of the BPM engine, but BPM needs to track to know when they're done. So a great example is how we do our integration with a ticketing system like Jira. Jira, we don't expect to come in and replace your ticketing system. So, we have support for things like Jira and ServiceNow, et cetera. And we treat those as external activities, because basically we track those and we pull those and we look for updates to those. And we do that with a different enterprise class systems, because we need to bring those into the model lifecycle. If we don't integrate with those kinds of investments you've already made within your organization, we're not getting the best value out of both of our products. So the idea is ModelOp Center integrates with all of those business class solutions and enterprise grade scale things. And we do that through these external activities that we track. And then we'll continue the process on when that external entity tells us that the appropriate status has been reached. And we'll show you how we do that with Jira today and how you actually bind to that. I do want to point out there's also the concept of a sub-process. This is where we can actually create a whole process definition and then just link it into our different diagrams, so we can reuse things easily between applications if they're consistent. So things like how we create a Jira, for instance, or maybe the test cases we run, or those kinds of things. Those can be shared between the different process definitions as sub-processes, and but have access then to the specific variables that the outer process defines. So really just a reusability idea. I think of it like kind of like a library we use to get things done. Then finally, the last major component we're going to be dealing with, and is one of the bigger powers of BPM, is the idea of gateways. We're going to be using gateways to basically control the flow of the business process. A big one, and probably the most commonly used one, is what is referred to as an exclusive gateway. It basically controls the flow based on the values of one of the process variables or a scripting result, or other things within the process, and actually makes basically decisions about which way we should go. So for example, down here, you can see one we have defined on that. But the parallel gateways also allow us to parallelize a couple activities and rejoin the process once we wait for them to actually be complete. So we can execute 5 or 6 different things that have to occur at the same time, and that allows us to split those out and rejoin those. And we have inclusive gateways that just make sure all of the flows are actually evaluated that come out of that specific gateway. As I said, we're going to be using exclusive gateways quite a bit. The way they kind of work is that there's going to be explicit matching criteria for each of the individual flows, and those will be executed first. Now you can then at the end have a default path, which is indicated by this slash mark, which says if you don't match any of those other flows, well, then go that way. So they're very standard kind of a logic pattern, but really get quite powerful in the different things we can actually do. And we already mentioned the sub-processes that allow you to reuse those. So what does ModelOp Center specifically provide? Well, we have quite an extensive list of different items that we have within our flows. And I'm not going to go through all of them, but I'm going to point out some major ones. So for instance, we have a good collection of signals that tell you what is going on within our system, so that then you can design processes based on what's going on within ModelOp Center. So like for instance, if a model has been updated, we have a signal and you'll get an instance of the model in one of these process variables. Or a job, excuse me, a status has changed within it, like maybe it went from created to running, or it went to error, or those kinds of things. And again, all of these will give you objects that change, so you can then do stuff with that within your process definition. One we'll be using today in specific is a deployable model has changed, basically saying that a new version of the model has been created that's a snapshot of the model in time. So, we want to go run tests on it and do things like that and things. It's a very, very common one to utilize within your model lifecycle. Another one is a notification is assigned, or something has occurred within one of the processes, within one of the models or the tests or that kind of thing. So once that has actually been, an assignment request has been put out to it, we'll get a notification that has heard. So we'll get that signal to start, as well as like a deployed model has been created or updated. So maybe a new model has been deployed out to one of the servers, and we want to go do some cross checks on it and things like that. So we have those kinds of signals. We have many, many more signals based on all the different kinds of things that could occur. And we have Java docs on these for actually being able to understand what goes into them. But the delegates, that being the workhorse of what we actually want to do, we have quite a few different kind of classifications of different delegates that can perform operations within the ModelOp Center. So for instance, we can deploy a model to execute a long-term kind of binding to a runtime environment. So we actually stick it on there. We could also execute a predictive batch run on a runtime environment. So we can basically do like think of as running a weekly report, or basically executing the model with an input and then and capturing the output and then returning the status of that. So we have delegates that let you just do that by passing in a few parameters. Finally, we also have one we'll be doing today is executing a metric job to actually run some test results on a model. And we have a delegate that makes that easy too, by just giving us a deployable model and some information about the data that you want to run on it and specific on that. Another common class of the delegates that we have within things is basically to interact with all the data that we store within the model manage within ModelOp Center. That basically allows us to basically update the models, or add notifications, or look at the runtime jobs, what's going on with them, or create a job, or any of those kinds of things. So we can do all of those as well. And finally, there's like basically managing those external tasks we talk about that's critical to your business, and then you've already made investments in. So for instance, we have ones for Jira and ServiceNow to basically be able to link those into the ModelOp Center data and generate tickets and interact and track those within your process. And finally, they also can interact with any RESTful or SOAP-based service within your enterprise. So even if we don't have a delegate for your specific needs, you can go out and actually still interact with those systems as long as they provide some kind of a standard API to do that. And then those would be treated as an external task. And we'll show you how you do that today as well. So that's a little bit of, yes.
Hey, Jim, there is a question you kind of answered briefly, but if you can elaborate more, can additional signals be configured? Meaning deployed models has fallen below threshold performance?
Yeah, how we would actually do that is, and we'll show a little bit about that, but what we would do, and we'll show how we evaluate test results. But for instance, we would either, I'm going to use a simple example of running a back test because that's easier to explain. But let's say we ran a back test and actually looked at those results and it was below a threshold. Absolutely, you can send a new signal out. The signal definition is just literally a signal name within the file, and we'll look at those. So you can create custom signals, and then obviously you could, as we showed, you can have a start event of that signal. So you could actually have one thing testing in the background, sending out an alert basically saying, hey, this fell below, and sending out a signal that starts other processes or other things. So absolutely, you can do that. You can even actually implement your own delegates in Java and put them on the class path, and they come out too. So by no means are we restricting any of that functionality. In fact, we just want to provide a very robust library of those to actually make it easy so you don't have to do that. So today, what we're going to do is we're going to jump in hands-on now. I've got a little more slides up front. I apologize for that, but I wanted to give the background. We're going to build a simple hello world process real quickly, just to show you the mechanics and how we deploy it, and using one delegate. And then we're going to build a little bit more complex of a process where we actually use a ModelOp Center signal to start it, and we execute the metrics job, and we actually create a JIRA ticket then for review. So a simplified process of the demo, but I'm going to do that from scratch so we can see how we actually build those up and deploy them. With that, we're going to jump into the hands-on portion and get out of the slideware here on that. So let me bring up the modeling tool here. So we're going to do, and I'm going to cut and paste a few things just in the interest of time, but we're going to create a new BPMN diagram and actually go out there. And what we're going to do is, so I'm just going to grab this to make it a little quicker for us to build that up. And we're going to delete the one that was there. And so we're going to add a start event of a timer. So every minute you can do that. And you can see right here, there's a timer definition field. When you highlight any of these, you can change the type based on clicking the little tool, or we can when you click on it, it'll give you the options that you need to actually set. So in this case, we're going to go by a cycle, meaning it just repeats itself, and you can see we do every minute on that kind of thing. So a pretty simple flow. And I'm also going to grab a real quick script process. Again, I'm just cutting and pasting these. It's a little quicker to bring over. So this is an actual scripting process. So, we can examine data or whatever we want in there. So, for instance, we could print, we're just going to put a little groovy script in here. That's very simple. On there. And, you can put whatever groovy script you on there, and you can see you can actually change that to any other type, as well as we could actually reference an external file if we want to, but we're going to do an inline script there. And then we're actually going to go grab one more off of here, which is we're going to grab a notification delegate. Now, this is one of our delegates that's actually there. And basically what it does is it creates a notification within ModelOps. Now, you remember we talked about the process variables that are to the process. Delegates can also have variables. So when we highlight that, we can see there we're referencing our process notification. Now, right now, we're working on adding plugins here to make this a little bit easier. We don't quite have those yet, so you won't have to put in the class name. You can select it from the tool menu. But for now, we're just going to specify it by the actual class name of the delegate that implements it. And then it has a series of input and output parameters. We specify those in the Java docs that we have that describe the different items for each of the delegates that's needed. We can simply give it a message text. So this is the input one. Basically, we can say, hello, ModelOps. So we can basically give it a message and to actually go out, and that will become the notification message we'll see in the console. And we can give it a severity of the standard severity types. In this case, we're just going to do info. We could do error. We could do warn. We could do all of those different things. And finally, we're going to want to basically have an endpoint. All processes must actually have an endpoint, and we're just going to terminate normally. Now we're going to go ahead and link all those up to basically go and indicate the flow. As you can see, this is a pretty simple flow here. So we have our flow, and I'm going to have to save that real quick. Let me grab that. Call it hello. We'll go ahead and save that. So we have a name on that, and then we could give the process a name as well. So that's the name of our actual process. Now, if we go over to ModelOp Center and actually bring up our view here, we're going to look at the item here. Let me close that real quick. Okay. So we can go to the MLC. We'll see currently we don't have this up there. We have a few pre-installed items. To actually get into the system, this is one of the reasons we use Command Modeler tool. We could copy the file out to that place or put it in a shared drive or that kind of thing, and it would automatically get loaded. But the Commando allows us to basically put it right in there. And we can put it in there, and you can see we're actually just connecting to the endpoint within the MLC server. And I have authentication turned off for the demo, but we can go ahead and actually deploy it in there. It'll tell us the result of that. But now when we go back to ModelOp Center and refresh the model lifecycle view here, we'll see our new process actually within there. So now our process is actually loaded within the system. And basically, it's scheduled, if you remember correctly, to run every minute. So basically, every 1 minute, it'll go through and run that little bit of a Groovy script. And then it'll actually create the notification process. So you can see it just ran there. Now, if we go back to the ModelOp Center, remember we have the basically the ability to add these notifications. So we added a simple process notification from within the process, and there's our message. And we could add additional details to that notification if we wanted by using some Groovy to add additional items to the models and stuff. You can see just how easy it is to actually build a tiny process that actually does all that work. So now that's obviously a very simple process and not so useful. So let's build out something that would be more realistic on the items. And again, we're gonna kind of steal from this diagram to just make it quicker here for the cut and paste. So we're going to go in here and we're going to start on a different start event this time. We basically want to know when a deployed model is created. So here's one of those signals where basically we're saying when a deployed model has changed. Now we're looking at any change. We would filter this by created if we wanted to on that kind of thing, just capture created. But for today's demo and brevity of time, we're just going to go ahead and use that. But that's one of these signals. It's coming from ModelOp. ModelOp is in the background listening to this and publishing these items on a WebSocket. And meanwhile, the MLC server is listening for these items to occur live so it can get it. And it's also, they'll be rebroadcast if they're missed on that kind of thing. So we're going to go ahead and then grab another item, which is really what we want to do is we're going to use a very simplified portion of this diagram here to pull these in. So we're going to basically create a test run on that data. So we're going to grab that in. And this is a Groovy script, if you'll notice. So what we're doing, and I apologize, their scripting interface is not the easiest in the world, is what we're going to do is we're basically, see, we've got this deployable model. That's an output variable from the signal. So it contains that deployable model item. And basically, we're going to look at it and we're going to find the test data that's associated with that. So you'll see we just go model assets find, and we're going to grab that test data, and we're going to set that as the input to the test job, set the variable input file to that. And then basically, we're going to set the output file to just a test out.json. That's going to be stored in a temporary file on that kind of thing. And then we're going to set the job type to model batch job. So you can see where we're setting up all the variables. So rather than statically setting those like we did in the hello world example, we're setting those programmatically through Groovy. So we're determining those directly from the data of the model, things like that. So that way we can ask the model what test data should it actually be running. And likewise, now we're ready to actually run that test. So we're going to go ahead and bring this delegate in. this delegate actually creates a model batch job. So basically, we're going to go and take the inputs and outputs on that. You can see we didn't specify the inputs statically because that wouldn't work for a generic process. We did that within the Groovy script. We set those required parameters to create a job, and then we're going to capture the output in test job, and we're going to put that value. So the delegate's going to give us the job, and we're going to set within the process the test job so we can monitor it. And then I'm going to grab a few of these at a time for the sake of brevity here again. Let me just shrink this a little so it's a little easier for me to do. I'll grab this one. I'm going to grab a little things. This really tends to be a sub-process, which would make our life a little bit easier on that. So we're going to grab those three, and we're going to bring them all in at once into our new diagram. And we're going to drop those in there. Shrink this a bit. No, I'll make it big again, but I'm going to move this up. Move this up here so we'll do it. Now, normally I'd be a little neater on this. We're going to be a little messy here, so bear with me on that. I'll zoom back in, shrink this down a little bit. We're going to make it really messy just for the sake of brevity here. But basically, what we're doing is now we want to actually monitor that job. So we're basically saying, hey, wait for the test. We're just going to sit here and wait. And then what we're going to do is whenever the job is updated, we're going to receive that the job is updated. So it's one of those boundary ones, and we're going to go off and then actually check the status. And if it's error, we're going to go create a JIRA test review notification. And if it completes successfully, we're going to look at the test results and do something with them. So we're going to do that. Now I'm just going to briefly link all these up here. So in the interest of time, so we can do that. You can see where we're just pulling all these together and building out our flow. And, you know, we're going to have this process, and that decision gateway is looking. And if it's not complete, we're just going to sit there and loop. Now, in the reality, we'd have a job timeout to kind of get some regulations. We're going to take that off for brevity today. And then we're additionally going to basically, let me grab a couple more here. What we're going to do is actually then use these delegates here to basically manipulate some data. So we're going to add those test results into Model Manage so they're persisted. They're in the job right now, but we want to actually persist those as model test results. So you can see where we have a create model test result. And it basically takes an output parameter where it'll give us back the fully populated model from Model Manage. So we're going to take those test results out as the model test results, and we're going to add them in and persist them within Model Manage. And then we're actually going to do an eval on these. Now, this, if you remember from the last session with the decision tables, that's what this is doing. So this delegate literally just takes in the basically the model test results and basically looks them and runs them on a BPMN and outputs pass or fail on that kind of things. And finally, what we're going to do is actually we can share these two together. Let me grab these three. Now what we need to do is an abbreviated process where we're just going to create a review here. So we're going to bring in these three items here, where we're actually going to go create a JIRA review. We're going to store that notification, and then we're going to wait for it to actually be complete. Now what we want to do is actually bring it through here. Now again, I'm just being really messy. Normally we move these lines around, but this is makes it a little more live. Maybe we'll move it out there a little bit so it's not quite as much in the way. And then likewise, we want to, the successful one, create a JIRA review rather than this one was the job failed. This one is it succeeded. For both of those, we're ultimately going to want to store the notification. But the create JIRA, we've done, you can see, we also have a create service now, et cetera, on that, where we actually put the input and output fields. We just pass in the keys. Now, these can be programmatically determined. But the big one is the exit status. We're basically saying don't quit until you hit one of these statuses, because JIRA lets you define anything you want. So we're saying if it's done or rejected, go on that kind of thing. Then actually, this one's very easy in that you just store the notification. So again, it says data update within the items. And we're finally going to have the wait for review. That's that external process that ties it together. You just give it a topic and say, and it will sit there and poll and wait until JIRA tells us it's done. We do that for you automatically in the background, so it's all done. And finally, we're just going to go ahead and actually terminate this process when we're actually done, because it's all there. And we're going to set that to a normal terminate end event. That's it. This is messy. We'd clean it up normally, but you know, this is the way we're going to do it for right now. I call that one the model. So we're going to go ahead and actually call that model review and save this. And again, we can just upload this straight from here into the server. And we're going to go ahead and just deploy that up there. And it actually deployed successfully, as you can see. So now we can go to our ModelOp Center, and we can see that it's actually in there. I think I have to refresh. A second. There we go. So now you can see we've got our model review one, our very messy diagram in there. So quickly, we're just going to go out here to GitHub. We're going to import a brand new model and submit it through our process so we can see our item actually work. Grab the one we used in the last item. So I'm just grabbing the URL here so we can import it. So we're going to go ahead and grab that, go out to ModelOp Center. I'm just going to bring up another window over here. And basically, we're going to go in and actually import that model into the system real quick from Git. And that's this model we're bringing in because it has the BPMN table, it has test data, has everything associated with it. That little process we make can actually run it all through to end and do that. So this model, we can see we have those attachments of the test files and stuff. We also have our DMN associated with it. So now we're going to go back to the model here, and we're going to go ahead and submit the model as a new version. And when we do that, we'll see our new process just started. So now it's actually running. We're waiting for that test to complete. It created that batch job. It's actually firing it off out there. And then we're actually going to basically, once the job is finished running, it will actually go on and parse those results and run through our new diagram that we actually created here. It takes just a minute for it to be done. You can see it's done. It went out. It's now created a review. Now it's sitting on that external process, waiting for it to actually go on. So if we go over to Jira real quickly here, we'll actually be able to see that new ticket we actually just created, projects demo, within the project that we specified. So we've got that item where we actually did that, and we created it in there. It can take us to those test results. The delegate did all that work for us. It's basically generated a standard message, and etc. You could override that with whatever you wanted it to say, but we do a standard one, and we can link right out to the test results from that simple thing we did. But more importantly, we can go ahead and hit one of those states we said was an end state. We can do done, and when we do that, we'll see that it'll actually complete. So there's our whole process. So there's kind of an end-to-end flow showing how we can pull all these pieces together, kind of drag and drop, and use those process variables to communicate between the different stages and different steps of those items, and actually design a full model lifecycle from scratch. Although I suggest you start with the ones we already provide you, because they'll do a lot of the work for you on that kind of things, and you can modify them, but you can update them as you feel free and just immediately deploy them from the tool directly into the ModelOp Center, so your lifecycle can continue on and evolve. Because once Camunda does a great job about versioning these. So for instance, if you start down a path, it's going to stay on that exact definition, because otherwise, if I deleted one of these steps, you could be lost. But if I deploy a new one and a new one starts, it'll follow the new process. So you have a lot of power with that. So I know we covered a lot today, and a lot more in depth. There's a lot more you can talk about. We could go on for days about basically BPM and model lifecycle and stuff. But I did want to give you at least a brief introduction here of how we put those together and the lower level details of the kind of the capabilities we provide, and how it's a very unique way of approaching a model lifecycle, because it can grow with your company and, more importantly, integrate with your existing investments.